So the last problem we're going to do is number 12, which is a polyatomic ion. And I know right away this is a polyatomic ion because of this plus sign. A poly, remember, means many. Ion means it has an unequal number of electrons. So it's just like writing Na plus, but it's just a compound with a charge. What you're going to look at there is it has a plus 1 charge. And I know that when something has a plus 1 charge, it has lost 1 electron, and that is going to come into play there. It has lost an electron to become positive. For the beginning part, everything's the same. As we've been doing, I'm going to write N and H4, identify their groups, V for valence, P for probable. So nitrogen's going to have 5 valence, hydrogen's going to have 1 times 4, which is a subscript for a total of 4. So my initial count for the number of valence is 9. Now here's where the charge thing comes into play. Only for your valence count, you're going to take into account this. In order to become positive 1, this element has lost 1 electron. Only for your valence count, what you're going to do is subtract the charge. So instead of 9 electrons, I should be showing 8, because in this compound, you have lost 1 electron. So you don't have 9 valence electrons, you only have 8. You only do the addition and subtraction to the valence, not the probable. The probable is done like normal. So in a 5A would most likely have 8 valence. A 1A would have 2 times 4 to get 8. And 8 and 8 is 16. Notice, I'm not changing that number at all. So only for the valence electron count, you're going to add or subtract according to the charge. In this case, it's plus 1, which means it has lost 1 electron. So to get my bonds, again, everything else is now normal. 16 minus 8 is 8, divided by 2 is 4. So I want to show 4 bonds. Completely normal, that math. Out of nitrogen and hydrogen, nitrogen is most likely to be the central. And the easiest way to connect 4 hydrogens with 4 bonds is with 4 single lines. So if I do my checks, I'm showing 1 nitrogen, 4 hydrogen. I'm showing 4 bonds. And actually, in this case, I'm showing 8 valence electrons already. You notice when you have a hydrogen atom, that tends to happen. I'm going to erase this real quick because the only other thing you have to do with a polyatomic ion, you have to kind of indicate somehow that this is a polyatomic ion. It's not the formula NH4. So the way you do that, only for polyatomics, only, you put a bracket around the whole structure, and you write the charge in the upper right-hand corner of the bracket. That indicates to the reader that basically you've done this part, that you've added or subtracted an electron. And remember, with the polyatomics, you only alter the number of valence electrons, not the probable.